ईयर स्टूडेंट्स, अगर आप इन वीडियो लेक्चर्स का मैक्सिमम यूटिलाइजेशन करना चाहते हो तो आई थिंक आपको ये इंप्रूव सेशन डेफिनेटली फॉलो करना चाहिए और रिलीजियसली फॉलो करना चाहिए। इंप्रूव सेशन क्या है, इसका लिंक डिस्क्रिप्शन बॉक्स में है, तो जाओ उसको चेक करो। इसके अलावा अगर आप व्हाट्सएप ग्रुप ज्वाइन करना चाहते हो, और मुझे लगता है आपको करना भी चाहिए, तो आप क्या करो, हमारे वेबसाइट पे जाकर के अपने कॉन्टैक्ट डिटेल्स दे दो या फिर इस व्हाट्सएप नंबर पे जाकर के अपने कॉन्टैक्ट डिटेल्स दे दो, सो दैट हम आपको उसमें ऐड कर सके। चलो अब पढ़ना शुरू करते हैं।
Hi, this is a problem solving session for JEE Mains Archives, and the topic is work power energy. So let's start. The first problem says consider the following two statements, and option A, linear momentum of a system of particle is 0, and option B is kinetic energy of the system particle is 0. So these are the two statements, and these options like basically saying like which one implies which one and which one does not imply which one. So let's talk about the linear momentum of the particle is 0. So I can have the simple scenario, one particle m v, another particle m v negative. So if this is v, this is the negative v. In this case the net momentum of the system is 0, but as you can see the k of the system is non-zero because this is going to have a different speed, this is going to have a different speed, and kinetic energy is never negative. Okay, even the momentum is negative. So in this case, although the momentum is 0, k is not 0. So p is momentum is 0 but k is not 0. So if like statement A is correct, that does not imply statement B is also correct. Now if k is 0, that means speed of the system, like the speed of the each particle in the system is going to be 0, and if speed is 0, velocity is also going to be 0. So consequently, even you're going to write p1 plus p2 plus p3 for the net momentum, each p component is going to be 0. So the momentum of the particle is going to, or the system is going to be 0. So B implies A, but A does not imply B, and that's option C. A does not imply B, but B implies A. Okay, now move on to the second problem. A wire suspended vertically from one of its ends is stretched by attaching a weight of 200 Newton to the lower end. The weight stretches the wire by 1 millimeter. Then the elastic energy stored in the wire is, for this the derivation part is there in the the properties of the material chapter. So here I'm not going to derive it, I'm just going to give you the formula, that is half into F into the elongation, stretching. Okay, so F is the external force which is used to stretch the wire, and delta X is the elongation. So using that formula, you are just going to write half into 200 into 1 into 10 to the power minus 3. Okay, so just calculate it and that will be your answer. Half into 200 into 1 into 10 to the power 3. If you are going to do it, this is going to be 100 into 10 to the power minus 3. 100 into 10 to the power minus 3 is 10 to the power minus 1, and that is 0.1 joules. Okay, try to derive it although, but we are going to discuss it properly in the next coming chapter, properties of the material, not now. Okay. Question number 3, a spring of spring constant 5 into 10 to the power 3 Newton per meter is stretched initially by 5 centimeter from the normal position. Then the work required to stretch it further by another 5 centimeters. So we have discussed, in case of the spring, work done by spring is half into k into xi square minus xf square, where xi is the initial deformation and xf is the final deformation. So using that formula, you're going to write half into 5 into 10 to the power 3, and xi is going to be 5 centimeters square, so 5 square minus, and xf is another 5, so 5 plus 5 becomes 10. Okay, so this is 10 square into 10 to the power minus 4, because that is in centimeters. So you're just going to calculate this value. Okay. Let's move on to the next problem. Body is moved along a straight line by a machine delivering a constant power. The distance moved by the body in time t is proportional to. Okay, so again I'm going to give you the framework how to solve it, and it would be better if you solve it yourself. Okay, so just see this problem, and for every problem, pause the video, see the problem, pause the video, try to solve it yourself, and then if you're unable to solve it, see the hint what I'm going to tell you, and then again try to solve it. So in that case, that learning process is going to be more pronounced. Okay, so it's saying that the body is being delivered a constant power, so power is F into V. Okay, this is the general case of the power. This F can be variable, this velocity can be variable. In this case, constant power, that means F into V is constant. F into V constant means F is equal to M into A into V. So power is M into A into V. This P is constant, so I can write A V is equal to P by M, constant by some mass, again it's a constant. A into V is equal to some constant K. Okay, now we have this equation. Remember, this A is equal to dV by dt, and so this is going to give me dV is equal to A dt. Now dV is equal to A dt and A is function of V. You should be able to see this A is K by V, so I can write dV is equal to K by V dt, and that becomes V dV, okay, is equal to K dt. Okay, just see it. I'm just going to replace A is equal to K by V, so V comes here and V dV is equal to K dt. So here I'm going to get my velocity or the speed as a function of time. Okay, so since it's moving in a straight line, along a straight line, so the speed is also basically your velocity. Okay, V dV is equal to K dt. So I'm going to integrate it, I'll get my velocity as a function of time. Okay, now if I get my velocity as a function of time, I can use V is equal to ds by dt, and using that I'll get my displacement or the distance moved by the body as a function of time. I'll integrate that as well. So if you want me to solve it, I'll just do it. Okay, so I have V dV is equal to K dt, right? V dV is equal to K dt, and if I'm going to further solve it, V dV is equal to K dt. So here just see V dV is equal to K dt. Integrating this is going to give me V square by 2. Suppose initially the body is starting from rest, so V square by 2 is equal to K t. Okay, so this is going to give you V square is equal to K 2K t, or V is equal to some K dash into root over t. Now this V is also ds by dt, speed or the velocity, and this can be distance or the displacement since I'm moving in a straight line, and ds by dt, and we are going to assume that the body is not changing its direction. Okay, so for the time being, ds by dt is going to be K dash into t. Now this ds is going to be K dash root over t dt, and then this integration is going to give me some proportionality constant K double prime, and this is going to be t to the power 1 by 2, and that becomes t to the power 3 by 2. So that is the answer. Okay, let's move on to the next problem. A particle moves in a straight line with retardation proportional to its displacement. Its loss of k for any displacement x is proportional to. Okay, so we have been given that the retardation is proportional to the displacement, so I'm going to write something like a is proportional to minus x. Why? Because if x is taken as displacement and this is positive, so a is going to be negative because it's acting in the opposite direction. Now the loss of k for any displacement x is proportional to, so we do have this v dv is equal to ad x formula. Okay, and I'm going to integrate it. This is going to give me v square by 2 minus u square by 2, so initial going from u to v, and this is going from 0 displacement to some displacement x. So if I'm going to solve it, this is going to give me v square by 2 minus u square by 2, and this is going to give me a is proportional to minus x, so this can be written as a is equal to minus some lambda constant into x, and in this case a is equal to minus lambda x, so I can take minus lambda outside, and this is going to be x dx. That integration is going to be x square by 2, and here I have v square by 2 minus u square by 2. I'll just multiply left hand side with m and right hand side with m, so left hand side becomes m v square by 2 minus mu square by 2. That is basically your change in kinetic energy, and the right hand side is minus lambda into x square by 2. Okay, so again you can see that change in kinetic energy is proportional to x square. Okay, so the answer is going to be C. Again, solve this equation if you just if you want to get the exact value or the fundamental formula in m and lambda and stuff. Okay, now move on to the question number 6. A uniform chain of length 2 meter is kept on a table such that length of 60 centimeter hangs freely from the edge of the table. The total mass of the chain is 4 kg. What is the work done in pulling the entire chain on the table? So we have done this same derivation in the previous video. So this is going to be the chain, and some length is here. Suppose this length is L, and this length is total L naught minus L. Okay, and work done is pulling the entire chain on the table. So work done by F external plus work done by gravity has to be 0 because it's done slowly, and work done by gravity, work done by force external is going to basically work done by negative of work done by gravity. So negative of work done by gravity is basically the change in potential energy of the chain. Okay, so you're just going to use that potential energy formula. Potential energy of the chain is minus mg L by 2n square, where n is the fraction. Okay, so how you're going to calculate the fraction? The length is 60 centimeter and total length is 2 meters, so you can figure it out. This 60 is total, or 60 centimeters 0.6 is basically 2 divided by n, and from here you can figure out the value of the and put it back in this formula. That is going to be potential energy of the chain in the initial situation. Okay, and then again the final situation is going to be 0 because you're going to assume at the table level the P is 0. From there you can calculate the work done by the gravity, and negative of that is going to be the work done by the external agent. Okay, so this is just using this formula and no fancy calculation is required. You'll do it and you'll get your answer. Okay, let's move on to the next problem. A force F is equal to Fi plus 3j plus 2k is applied over a particle which displaces it from the origin to the point r is equal to 2I minus j. Work done on the particle in joules. This is nothing but F dot delta S. So you have this F given, you can calculate this delta is starting from origin, so this is basically delta S. Just take the dot product of this force with this displacement, and that is going to be your work done. Okay, so let's move on to the next set of problems.